All right. Who's ready to get started? Are you guys enjoying HTML5DevConf? Yeah? I think it's pretty awesome. I'm having a good time. It's great getting out here, being able to talk to each and every one of you. My name is Andy Trice, and I am an evangelist with Adobe. And I like to treat these as conversations. If I'm talking about something and you guys have questions about it, feel free to raise your hand. I will try to answer your questions as best I can. Apologize in advance for my voice. I talked a lot yesterday, and now my voice is almost completely gone. So that would be why I'm like downing water like crazy up here. So today I want to talk to you about designing and architecting for PhoneGap and the mobile web. Now, I'm not going to sit up here and preach and say there's one way that you need to build these kinds of applications, because there's a different way for every application. It all depends upon what your current skill sets are. What does your app need to do? How many different backends are you trying to integrate with? What kind of data services? Are you making a game? Are you making an enterprise app? It's all really dependent upon your specific scenario. So I'm not going to sit here and proclaim like, oh, use XYZ framework because it's the best, because that's just not the case. Now, it's pretty straightforward when I'm talking about architecting for the mobile web. We're talking about architecting applications for mobile browsers, so the browser running on a tablet or a smartphone, regardless of the operating system. When I'm talking about architecting for PhoneGap, the architecture itself is going to be very, very similar, because PhoneGap by itself is essentially natively installed mobile applications that are written with web technologies. So it works such that, and I have to do the obligatory intro to PhoneGap for you guys that already know how to do it. But the way that PhoneGap works is your application's interface on the device is essentially a web view that's 100% width and 100% height. And everything inside that web view is made up of your application. So all navigational components, all content, whatever kind of images, interactions, animations, it's all HTML, CSS, and JavaScript. And PhoneGap gives you the ability to tie into native operating system functionality. So there's an API that purely from JavaScript you can access sensor information like accelerometer, GPS, compass. You can search the contacts on a device. You can access the file system. You can record video. You can take pictures. You can record audio. You can play sounds. You can do all kinds of really cool things without ever having to drop to native code. And what's really awesome about this is that because PhoneGap supports multiple platforms, you can take this one code base, which is based upon HTML, which can be rendered everywhere, and you can bring it to iOS, you can bring it to Android, you can bring it to BlackBerry, Windows Phone, Firefox OS, Tizen, Ubuntu OS. Some of those platforms like Tizen and Ubuntu and Firefox are really new, so it's not going to necessarily be exact same experience as iOS, but those platforms are developing, and as they develop further, it's going to be a consistent experience across all those platforms. And the third part of PhoneGap is that it allows you to take all those the assets that create your application and your interface, the HTML, the CSS, JavaScript files, package them up, turn them into an archive that you can then upload to standard application ecosystems. So you can put it in the iTunes Store, in Google Play Market, the Amazon App Store, the Barnes & Noble Nook Market, BlackBerry App World, Windows Phone Marketplace, Firefox Marketplace, basically all the standard ecosystems for each one of those different platforms. Now, when we're talking about architecting for PhoneGap, architecting for the mobile web, we're talking about architecting similar things, but we also need to understand how this is going to be different from architecting a native application. If you guys saw my intro to PhoneGap presentation, these slides might look a little bit familiar, but I promise you this is the last one that's the same and the rest of them are going to be different. Now, when we're talking about all the way on a web application, we're talking about running inside of a web browser on a device. It's HTML, it's ubiquitous. It can run absolutely everywhere. If anyone has a phone in their pocket right now that can't render HTML, then it was probably created early 90s or earlier. It's accessible everywhere. Desktop, mobile, it's HTML. It's not installed on the device, so you're running in a limited browser sandbox. On the exact opposite end, we're talking about a web app, or excuse me, a native app. And a native app, you're writing that in whatever language is specific to that platform. So for Android, it's going to be Java. For iOS, it's going to be Objective-C. For Windows Phone, it's going to be C#, .NET. And you have different code bases that you would have to maintain for each platform. But as an advantage of native is that you're going to have the absolute fastest speed and immediate access to new APIs once they're released. PhoneGap essentially sits in the middle. We have the ubiquity of a web app, meaning it's HTML that runs consistently on all these platforms, and we can have one code base on all these platforms. And it gives you access to underlying operating system features, like I said, reading and writing the file system, searching contacts, doing all of that. But it's not necessarily going to have that ultimate performance or access to every single API that a native application is going to have. So, it's really important to use the right tool for the job. And so I never want to be telling people that, oh, use PhoneGap for absolutely everything. Because if you're trying to write like a crazy 3D game, PhoneGap is not the tool for you to use. But it's an awesome tool for getting anything that can be done with HTML and getting it out in as many devices and app ecosystems as possible. So with that, let's talk about architecting PhoneGap applications. Now, when we're architecting PhoneGap applications, there's two things that you need to keep in mind. First, you want to develop for the user, meaning it's not just about reuse and maintainability, which happens to be my second bullet point, but you also want to think about how the user is going to experience the application, because the decisions that you make when you're architecting your app greatly impact the user experience. This can be everything from like loading times to slow performance, walking the HTML DOM. It can be your order of operations when you're manipulating the DOM. It can be touch interactions. There's a lot of variables. So you want to really design everything so that, one, you can easily maintain the code, and if you step away from the project for 6 months and you come back to it, you can easily pick up the patterns that you created when you were developing the application and build it, add new features, fix bugs, or whatever. But you also want to make sure that when you're building those patterns, building the structure, that you're building features of the app so that the user experience does not suffer. So let's take a step back and think of the old school web architecture. And with this, I mean, when you are accessing content, you're requesting data from a server, it sends you a page. You might click on a link, it goes back to the server, it pulls back another page. And everyone always says, well, it's PhoneGap, it's based on HTML and JavaScript. That means I can just take my website and turn it into a mobile application. And that's actually not always the case. It's not, I'm not saying you can't, you can in many cases, but it's not always that simple. Because what's happening behind the scenes on the server, it could look something like this. No one's ever seen a system that looks like that, right? But come on. There's a lot happening on the server side of things. If you're generating HTML, you could be using a server-side scripting language, whether it's PHP or .NET or Ruby on Rails. It could be pretty much anything. And there's a lot happening in there. Interacting with data services. If you're making calls out to different remote services to do an aggregation and generate that page and then return it back to the browser, there's a lot that can be happening. Now, every time you make that request from the client to the server, there's a couple things that happen. One, there's a latency when you're requesting information from the server, and then it's got to process it and it's got to send it back. And then when the new page is generated, then the old one is wiped from memory, it's gone. Yeah, it's in the browser history, but it's a very disjointed kind of experience. And when we're building applications for mobile web and especially with PhoneGap, I generally say to avoid this kind of architecture because it's a really disjointed experience to the user. Instead, I strongly recommend that you use a single page architecture method. And when I say single page architecture, I mean your application, once you load the initial HTML file, that there's basically nothing on the page. You load an application.js, and everything gets created dynamically in JavaScript. So all of your user interface is created dynamically in JavaScript, and you add and remove content from the HTML DOM as needed. Now, the number one reason, actually there's two reasons I strongly emphasize that you do this rather than loading multiple pages inside of the PhoneGap container. The first being that anytime you're going from one page to another inside of whether it's in a browser or a PhoneGap application, anything that's in memory in JavaScript is lost on the previous page once you go to the new page. So even if you go back and let's say you captured a bunch of data or you're saving some kind of user state, if you haven't persisted that in some way, it's gone, and there's no way to get it back. If you're doing a single page architecture method, you're always in the same actual HTML file. You might be changing things dynamically, you're executing lots of different JavaScript, but anything that's in memory remains resident in memory. So if you're saving user state, or if you are, have captured a bunch of data, whether it's you're tracking a GPS location, or if you're downloading content, you're doing some kind of data aggregation, data visualization, all of that stays resident in memory. The other thing is that when you're unloading one page and going to another page, it's extremely disjointed for the user. It's not a continuous user experience. The navigation changes, you have to wait for the page to load, you have to wait for the PhoneGap API itself to initialize, and it's very easy for people to spot pages that, or excuse me, apps that load in a page-by-page fashion and distinguish that they're not native because they don't have a true native user experience. And as I mentioned, a lot of this is really about the perception of the user, how they perceive the application to function, not necessarily how it truly functions. And if you're targeting iOS and you have apps that feel like one page from it to another, there's a good chance that Apple is going to reject them, because it's in the Apple user experience guidelines, it says that apps essentially must feel like apps. That if there's no distinguishing between them and a web application, then it will get rejected. So let's talk about the pros and cons, or not necessarily pros and cons, but where processing happens with these different architecture styles. So UI generation tier. If you're requesting a page from a server, the HTML is being generated on the server, transmitted up to the client. With the single page architecture, all the HTML is actually being generated on the client side. The language that you're using, I mentioned this earlier, on the server side model, it might be Java, .NET, PHP. But on the client side, it's all going to be generated in JavaScript. So you're actually generating HTML strings, turning those into DOM objects, appending those to the DOM. The multi-page method, if you want offline support, and in order to be approved in, let's say, Apple's App Store again, you have to have offline support. It can be very limited depending upon how you structure your application. But if you're in the single page model, you can detect network, once your initial HTML page is loaded, which is loaded off of the local device, it's not loaded off of a server, then you can detect network state, you can handle failover, and you can have a graceful response to any kind of bad network scenario. Page transitions, I mentioned browser, bad. Inside of a single page app, it all depends upon how you build the application. If you want hardware accelerated transitions from one piece to another, content sliding in from the left and the right, or fade in, fade out, however you want content to transition from one piece to another, you're in complete control of that. And then performance, like I said, the multi-page structure, because you have latency going back and forth to the server, it's very laggy. It's not the best user experience. But with a single page architecture, you can optimize how everything behaves so that it's a fast transition between content, and it's a very good user experience. Now, I mentioned that we're generating HTML strings on the client side. We're turning those into DOM elements, we're appending those into the DOM. And if you're trying to manipulate HTML strings in just pure JavaScript code, it can become very ugly code and very unmaintainable very quickly. And so I also recommend looking into templating libraries. Is anyone, has anyone used a templating library before? Okay, less than half. So that's good that you guys are doing that. Everyone else, I strongly encourage you to look into templating libraries. A couple different ones. There's mustache.js, _JS, handlebars.js. And what they are ways that you can create a markup that is going to be used to generate actual HTML strings based upon the data that you pass into the templating library. So, for instance, what we have here is a template that defines a list, and for each item that I'm going to pass into it, let me go ahead and show the data here also. If I can, oh, that's not what I wanted to do. So for each item in that list, and each item is going to be, or each item in the array of users, it's going to generate a list item, and it's going to inject into it an ID and a name. You can see each one of the conditional actions of the templating language, and this syntax with the 2 curly braces is based upon the mustache.js template library. And each templating library has their own conditional markup. But essentially, what's going to happen is the templating library is going to take that template. It's going to take the data, which is just an array of objects that contain ID and names, and it's going to combine those together to create an HTML string. The template itself gets parsed into a JavaScript function at runtime, and then you just call the JavaScript function, pass in the data, and out comes this HTML string. And this really helps when you're trying to abstract presentation logics or abstract presentation of HTML structure from your actual data model, which leads me into another thing I'm going to talk about in a second of separation of concerns, model, view, and controller. And the output looks something like this. We have a list that has some data in it. You know, we took that initial template, we put the data into it, it generated HTML, and it dramatically simplified our code structure. And to give you an idea of a little bit more advanced example, let me go ahead and jump over to the iOS simulator I have here, and I've got an app that's going to load any second now. Okay, so here I've got an app. This is a PhoneGap app. Whoops. And you know, I can scroll through my content, whatever. I can go ahead and rotate it. You can see it went from 2 to 3 columns. But if we actually switch over and look at the code that created this, the code is very, very simple. What I did was create an HTML structure. And this is not what I'm going to call a full application, but it's just a sample. And the main part of the application, we just have 3 divs. There's the header, there's a content, and then there's a footer. But we saw all those cards that are part of the UI in the center. So where did those come from? And if we look down a little bit further, right here, we can see that inside of this script tag, I've got some markup. So rather than taking the template out and putting it into a separate file, which you absolutely can do, and that's really helpful for maintenance of larger scale projects, I just put it in line here so it's simple. But basically, there's a div with the CSS class of card, which defines the shape of the card, how it's going to be presented. And in here, we've got a lot of conditional statements. So if there's an image in the data that gets passed in, we're going to put this div, we're going to give it a card image, we're going to give it CSS styles. We might put a banner in here, we might put a caption, we might put a tile and a message. And if we jump down here a little bit further, in JavaScript, we have an array called cards data. And in here, we have a bunch of JSON objects. And each one of those has whatever attributes that I want to be displayed inside of that HTML string that's generated by my template. And let's say if I want to go ahead and just go ahead and, whoops, let me zoom back out here. And let's say if I want to go ahead and change things, I could go ahead and copy this and paste it multiple times, hit save, and well, let me actually open this up in the browser so I don't have to recompile. And you can see that we've now got multiple instances of this first card because I just copied and pasted and I added more data to the JavaScript that was being invoked. And what it did was just leverage a template, which controls the HTML generation, pass data into it, and then from that data, we generated actual HTML for the UI. So in a nutshell, that's templating. And like I said, there's multiple libraries that you can use. And depending on your overall architecture, like if you're using a Backbone.js framework, it's got _JS already kind of baked into Backbone. You can use _JS for templating. That one was mustache.js. There's handlebars.js. There's multiple libraries that you can use to take advantage of to simplify your HTML generation using templating. So let's talk about code structure. I mentioned earlier about separation of concerns. So model, view, and controller. So there's different variations of this pattern. There's MVC, which is this MVVM, and there's just the basic concepts of you have a data model which is just basically objects that have attributes, and they represent pieces of data. Depending upon which kind of framework you're using, there might be a little bit of logic attached to your data to, let's say, have getter setter methods or events that are dispatched when data changes so you can support data binding. But you have concrete objects that represent pieces of information, and that's your data model. And then you have your view. Your view is essentially what I'm talking about here with the HTML templating. It's the code that defines what the presentation of your application is going to look like. And there's no logic built into it. It's just purely what's the structure, and then how's the CSS applied to it to represent the actual view of your application. And you can have multiple views based upon how componentized your application is and how modular your application is. But it's specifically when we're talking about views, we're just talking about pure presentation layer. And then we talk about the controller. So the controller is what defines interactions within your application. How is data loaded? What are the behaviors? What's the transition from one view to another? If user input occurs, how do we take that maintain state and have an action or a response based upon what the current view, the current model, and what the current user has done. So that's all the controller controlling behavior. Now, model view controller patterns can get a little bit complex. And when we're talking about PhoneGap applications, there can be apps that are really simple and they don't need MVC patterns. Like the demo application I just showed you doesn't use MVC pattern. I have lots of PhoneGap applications that are kind of smaller one-off apps that have been very successful, and not all of them use an MVC pattern. But when you get into a larger, more complex application that has lots of views, lots of moving parts, I strongly, strongly recommend considering an MVC architecture. But there's a caveat that introducing MVC patterns requires you to have more than just a basic knowledge of programming with JavaScript. It can get a little bit complex, and if you have kind of an intro level of JavaScript, it can be kind of cumbersome to wrap your head around all the different pieces. Now, if you're using an MVC pattern, you don't have to create one from scratch. There's a lot of frameworks that are out there to try and accelerate or augment your developer experience. On the left-hand column, I've listed a couple that I'll call full-stack frameworks. On the right-hand column, I've listed some what I'll call partial-stack frameworks. Now, full-stack frameworks are frameworks that really try and do everything for you. So there's a consistent coding paradigm across all pieces of the application. Like Dojo, jQuery, Sencha, they have their own programming structures and their own user interface and user interface styling, so that you just follow their conventions and it's going to come out looking like an app based upon how they've styled their components and their programming model. These ones can be really great for if you're like big team-based development, especially I know a lot of people that have been successful with Sencha in particular, like enterprise shops, because it enforces a JavaScript-based coding model and has consistent UI elements that can be used across the application. But what's also interesting about that is that when you're developing, targeting that, you're developing towards their spec. You're not, and you're programming JavaScript, but you're not necessarily writing HTML because it's using their API and their coding structures. So that's kind of a caveat that can be a huge benefit to some, but that can also be something if you want to hand write HTML and hand code everything and customize everything extremely, then that might not be for you. It all depends upon what your needs are. Partial stack frameworks are kind of micro libraries is not the right term for it, but each one makes up part of your overall stack for building an application. You've got your UI layer, you've got your application architecture, which is your coding structure and your patterns, and then you've got your DOM manipulation. So let's start at the bottom for DOM manipulation for the partial stack framework, where you could be using like jQuery or Zepto or something like that for pure DOM manipulation. So if you want to access DOM elements, alter it, change CSS, whatever, you would use something like jQuery for that. But then your application architecture, which this is what would be used to define your coding patterns, so MVC structure and just your code organization and the different patterns of how each module is structured and how the model, the view, and the controller work together, you could use something like Backbone.js, Angular.js, or Knockout.js, Ember, and this is just a subset. This is not a definitive list of every architectural framework. But what these are going to do is provide the structure for building an application. And they go hand in hand with the DOM manipulation library to generate HTML in kind of an organized fashion. But they're not going to do anything for you on the UI. And that's where I'm talking about the UI layer, where this could be something like Topcoat, which is a library from Adobe, Twitter Bootstrap, Zurb Foundation, Ratchet, Chocolate Chip UI. Like, there's a bunch of different libraries that are in existence that help people create web-based or HTML-based applications and make them feel like applications. So look and feel and the user interface paradigm. So making sure that whether it's tabs are on the bottom or the top, or the styles, the borders, the colors, everything kind of fits what an application should look and feel like on a particular platform. So that's in a nutshell. Like I said, there's full stack frameworks that try and cover everything from UI to architectural and coding patterns to DOM manipulation, and there's partial stack frameworks where you pick and choose which libraries you want to use. To kind of give you an idea of what I'm talking about with a MVC structure, let me jump over to another app. So here's an app I've got called 3Do, and this is a sample application that I put together. Whoops. Which apparently I don't have loaded yet. So let me go ahead and launch that from Xcode. So this is just a kind of a simple to-do list type of application. And we'll wait for the iOS simulator to start. It's like a to-do list application, but it has some interesting features. It integrates with different PhoneGap APIs. But what I've tried to do is structure the application, and I did this using Backbone.js, into finite elements that encapsulate specific pieces of functionality. So for example, in my directory structure here, might be a little bit hard to see. Inside the app directory where all my JavaScript lives, I have a views folder. And inside the views folder, I've broken it out to different components. So I have a list view. And in here, I've got Backbone.js, and I'm using Backbone.js to handle the basically structure of the application. Where I have, for a list view, I've got my initialize routines. I've got my animation routines. I've got when the view's shown. I've got all my different events that might happen within that view. And my rendering functions, it's basically everything that's for that particular list view. And I've got the associated HTML template that goes with each part of the list view. And I've also got a notes view. I've got a rename view where you can see the HTML for it. You can see the JavaScript that defines the structure of how that particular view should work. So basically, the MVC pattern here is that I've got views, which is actually each one of the individual HTML files, which are essentially HTML templates. And then I've got the JavaScript file that controls the behavior of that view and how it interacts with the other views that are around it. And so it's a very structured way of developing. And it leads to kind of like a more organized code base and more maintainable over time. And let's see if this is launched yet. So here's the app right here. I'm making some changes to it. It's in the middle of development still, so hopefully I didn't break anything. But we have a couple interesting things. So it's a to-do list. Let me go ahead and put in another item. So we have the list view, which was the first view that we were looking at. And apparently, yeah, I did break something when I was last playing with it, because my list view isn't rendering correctly. But you can see that there are items in the list. If I wanted to get rid of one, I can just swipe over and hopefully get rid of it. Yeah, I really broke this earlier this morning. But anyway, there's behaviors for the list. There's the notes. In the notes view, it controls behavior. I've got the button at the bottom, the other buttons that slide out. When I click on one of those buttons, if I wanted to go ahead and create a new note, I can do that. And Each view that's sliding in from right to left or left to right and back and forth is a separate instance of one of those different view components that I was talking about. So I've got my notes view, then I've got an HTML template that goes with that. I've got the list view, I've got the HTML template that goes with that. And then I have essentially an application controller that controls an application controller that is initialized when the actual page is loaded, and it defines the interactions between all those different views. So that's what I'm talking about with model view controller patterns. And it can be a little bit confusing, but I strongly recommend it for having a large-scale application that needs to be structured, and especially if you're doing team-based development. If you have 20 different developers working on the same app over time, they all need to be following the same coding patterns, or else you end up with a very spaghetti code, kind of nightmare, unmaintainable application. So another thing you want to think about when you're architecting your PhoneGap applications is you want to optimize data transfer. And this is not just something for PhoneGap applications. It's not just something for mobile web. It's something that when we're talking about basically any application is you don't want to be sending more data than the app actually needs. I'm sure all of you have encountered an application at some point in your life where you request data and then you're just sitting there and you're waiting and you're waiting and you're waiting and you're waiting and finally it loads, but it's only got like 2 pieces of data on the screen. But then if you were ever to go in and inspect the data that's coming across the wire, if you look at it and you think, why on earth did they send me 100 data fields when I only need 2? It's really important to kind of filter down and only display the data that's needed for whatever interface you're currently viewing, because this is going to reduce the amount of data that has to be transferred across the network, and that's really important when we're talking about mobile applications. And it's going to parse faster, and it's overall just going to be a much faster response. If you need additional data, let's say you're on one view and I'm on that list view and I have like 200 items and I only pull back an item, the name and the ID, then that list is going to view fast. But then when I need to actually drill in and get more data, well then just make another request to the server and get the data that you need for that item that you're drilling into. So lazy load data when and if that's possible, because and here's a caveat with that. Lazy load data when it's possible, when it makes sense. But if you are drilling into something and you make the request to get additional information, if it's going to be faster to load it all up front so that when you go into it, it's there, then go with that approach. But if you don't need to do that, and if you can lazy load it and request the additional information upon request, so only as it's needed, then go with that approach. So it's kind of like a balancing act. Like, what kind of scenario do you have? What's your system look like? What are your response times from the server? How long does it take to query all this data? You have to make a decision upon how much do I send, when do I send it. But it's something that you absolutely want to think about when you're architecting these mobile applications. Also, another thing, especially with PhoneGap apps, that you might want to think about are abstract components. When I'm talking about abstract components, I mean adding an abstraction layer to device functionality. Or not necessarily device functionality, but any piece of functionality. In this case, we've got a structure here, and I'm talking about notifications, the notification API in PhoneGap. If you wanted to do just a notification, pop up a message to the user, like sending a message to them, and you use a JavaScript alert, well, that works in the browser great. It works in PhoneGap great. But when you're in a PhoneGap application, it immediately identifies it as a JavaScript-based application because it comes up saying whatever HTML page is sending you a message. PhoneGap has the notification API. It's navigator.notification. I don't remember the exact syntax. Probably should put it in here. But it gives you a notification that doesn't look like a JavaScript alert, and you can put customized buttons in it, and you can make it feel more like a native type of application. But often, when you're testing and you're developing and you're going back and forth between a desktop browser for development and then putting it onto a device to actually test it, you might want to, the Navigator API isn't going to work inside of a pure web browser on a mobile device or a desktop web browser. So you might want an abstraction layer on it. So just saying, tell my abstraction layer to send a notification, and then the abstraction layer says, am I in PhoneGap? Yes. OK, we'll use the notification API. Am I in a web browser? Just use a JavaScript alert. And this way, you can have code that's portable across desktop and web experiences. Desktop and natively installed mobile experiences. And if you want it to run inside PhoneGap and the mobile web, but also it helps you with that developer workflow if you want to be really productive working in a desktop browser. And I strongly recommend that when you're building these applications to leverage desktop browser tools and the debugging tools. Like I develop 90% of my apps in Chrome, use the Chrome web developer tools because it's a very, very productive environment. A similar concept for an abstraction layer, let's talk about a data API. An abstraction layer on the data API can give you the ability to, one, go back and forth between a PhoneGap app and a desktop app, but it can also allow you to define where that data is going to be stored. So we have our app. Let's say we want to save data. We talk to the abstraction layer for the data interface. And then the data interface, depending upon whether in a web app or whether we're in a PhoneGap app, can determine, are we putting it into local storage, put it into the local file system, put it into WebSQL, or are we doing like a AJAX request to a server? And so it gives you the ability to have your general application structure and then the abstract layer determine the actual behaviors of each finite component of your application. Another thing that you really want to think about when you're architecting PhoneGap applications is to appropriately handle touch. And one of the first things that you want to do is make sure that you prevent the default behavior of the browser when you're touching something. And I'm not just talking about click events versus touch events right now. I'm talking about if you somehow manage to delete these CSS styles that are the default of every PhoneGap template, where WebKit touch callout, and these are specific to WebKit, but there's a touch callout, there's text size adjustment, and WebKit user select. Then anytime someone touches your user interface, they're going to be able to select elements, select pieces of text. When they lift their finger up, you're going to get like the copy, the copy command, and then it feels like you're working with a web page rather than a natively installed app. Likewise, also make sure that you're controlling pinch and zoom gestures by setting the viewport metadata tag, because if you have a PhoneGap application and you can pinch and zoom the whole UI, well, it certainly does not feel like a native app, and Apple will reject you for that. The other thing, I kind of hinted at this a moment ago, is you want to make sure you're handling user input in an optimized fashion. Mobile operating systems in general, and there's a caveat that goes with this also, in general have around 300 millisecond delay between a touch event versus a click event. So if I have an item on the screen and I touch it, if I'm accepting touch input, it's going to have an immediate response. If I'm listening for click events, when I touch it and I lift my hand, the operating system is going to actually introduce latency to determine, are you actually performing a gesture? And if you're not performing a gesture, well, then we'll dispatch a click event. And this can be really, really noticeable. I'm not on a mobile device when I'm showing this, but I've got a little set timeout in JavaScript to show you. When I click this, pay attention, when I click this button, I'm going to show two pieces of text. The first one is immediately upon when I hit it. The second one's after a 300 millisecond delay. So if I do this, you know, you can see there's a slight delay there. That's only 300 milliseconds. And you might be saying, 300 milliseconds isn't that much. But if you think about that upon every single user interaction, every time you touch a button or you touch a list item or you're trying to interact with it, it adds up. It makes your apps feel really slow. And they don't have to feel that way. You can respond to touch events and make your apps feel very fast. And when you're doing this, there's actually very little differentiation between how a native app might feel and how a HTML-based app might feel. One library that you can use to just take advantage of this is FastClick. FastClick will intercept touch events and then dispatch a click event so that you don't have to change the structure of your code, but it'll abstract that logic away from you and make your click-based interactions faster. Another thing that you want to think about is hardware acceleration. You can force any DOM element to be rendered on the GPU of a mobile device by using the CSS classes that I'm showing here. There's transform, translate 3D, and even if you pass it a 000 transformation, it's going to force it to be rendered on the GPU. This can make the drawing of it really, really fast. However, don't put it on every DOM element, because if you do, you're going to make your app slow and a memory hog. Because in order for a DOM element to be rendered on the screen, it has to be uploaded to the GPU. If you have multiple layers of HTML, and each one of those elements in the DOM element has hardware acceleration applied to it. Each one has to be rendered, put up on the GPU before it can be composited and then rendered to the screen. And each one of those takes up a chunk of memory, and there's more latency involved with the actual redraw of that. And sometimes especially on older Android devices, this can cause the device to go completely nuts and sometimes just totally crash your application if you force too much onto the GPU. What I recommend is having a container, put GPU acceleration on that container, and try and keep that container smaller than the minimum texture size for the GPU for the device. That's normally 1024 by 1024. It depends per platform. Like I know the iPad 3, iPad 4, it's like 4096 by 4096 or something. It's bigger, so there's a bigger GPU, bigger memory for it. But if you exceed that size, you might have like weird artifacts, you might have flashing, you might have like weird clipping events. But if you are below that size, it will make the interactions, like animations, more smooth and make it respond much, much faster than a non-GPU optimized version. The other thing that you can do is use hardware accelerated transitions between different pieces of content. So the app that I showed earlier, I should still have it up here. So if I click the button here, whoops, yeah, I broke it earlier. You can see that we have a transition from left to right for a lot of these, not all of them because I broke it. It's nothing like messing with code right before presentation. But you can see that there used to be an animation that worked there until I broke it. You can use Translate 3D to define where the new position should be and where the old relative to where the old position was, and use a CSS transition, set a duration on it, and then that's because it's using the Translate 3D for the animation. It's going to be a hardware accelerated animation from point A to point B. Very smooth. Mobile devices target 60 frames per second for that, and it feels very good. Feels native to the user. If you try and do an animation based on top, bottom, left, right, absolute positioning, it's going to go at like 5 frames per second because if you're animating on top, bottom, left, right, it's not hardware accelerated. But if you're using a 3D transform like this, it is hardware accelerated, so it gets rendered on the GPU. That's definitely something to keep in mind. And like I said, it can be incredibly helpful, but also use it responsibly. Let me see if I have another app on here that I think this one uses. Okay, yeah. If I click the button up here on the top right, you can see we have a nice transition back and forth. And the simulator is not accepting my click events, but whatever. You can see that we had some nice transitions. This might be an old version too, because I didn't test it before it. But anyway, you saw we had a nice transition right to left. It's very fluid. Even though I'm showing it on a desktop computer in a simulator, it is just as fast on a mobile device. I can show it to any of you later if you want, but that's because it is using that hardware accelerated transition from point A to point B. So let's go ahead and move on to optimizing for performance. When I talk about optimizing for performance, make sure your JavaScript is efficient, because slow JavaScript makes your entire application user interface feel sluggish. Here's an example. When manipulating some DOM elements, it's using jQuery syntax for every one of these lines of code. So when it's adding a click event handler, then it's changing CSS for the first one, changing CSS for the second one, then adding an attribute. Each time it's doing that, you can see the first section that we have here, it's doing a lookup on the DOM to find the element and then apply whatever action on that DOM element. You want to be very efficient with how you are how you're processing information, how you're walking the DOM. In this case, it's doing the exact same action, but it's only doing searching the DOM tree one time to get a reference to the element that needs to be updated, and then it's going through and it's adding the click event handler, then adding modifying CSS, adding the href attribute. That's going to execute faster than the previous example, and they do the exact same thing. So you just want to be smart about how you're structuring your application. Don't walk the DOM unnecessarily if you don't necessarily have to. Also, things to think about, and this is common with just web development, if you're targeting mobile web or you're talking about PhoneGap applications. But let's say we have an example here, and it's loading a bunch of different images. Each one of those images is a separate call to whether if it's a mobile web app, it's calling to the server, getting another image, so it's a separate request. There's network latency involved for those. If you're on a PhoneGap app and the images are local, it's still calling to the file system. It's got to load it into memory. There's latency involved with loading that image. That adds up over time. But you could use a sprite sheet, load the image once, use CSS to determine which part of the sprite sheet you should be loading, and it's only making a request to one image, then it's conditionally displaying it based upon whatever rules you've defined in the CSS for that particular image. It's reduced memory and also faster to actually load it into memory and render it. Another example, and this is quite common when people develop PhoneGap applications, is let's say you have an action, you request data, and then you want your display to be updated once your data is available. That makes perfect sense. You want your data to be updated once you want your display to be updated once you have that data. However, can someone tell me what's wrong with this piece of code? Anyone? Okay.
You should display the view and then update it with the product. Exactly.
Because it's waiting for the AJAX request to complete, your app, you might click a button, it makes a request, and it's just sitting there. And let's say you have a slow network, or even like if you're on a cell service, a 2G cell service out in the middle of nowhere, and your request takes 10, 15 seconds to complete, your app's just going to sit there, and people are going to start tapping the button, tapping the button, tapping the button, tapping the button, because it's not doing anything. It's waiting until the request completes before it actually updates the view. So the difference here being that it displays the view, then it makes a request, and then once your request is completed, go ahead and update that view with the new data. That gives immediate response to the user. It makes it a better user experience, and it's an overall better feeling, better responding application. And while architecturally it's not that much different, if you're thinking about how it impacts a user and the user perception, this is incredibly important, because what we want people to do is feel like you have a fast app. It doesn't matter if it's native, it doesn't matter if it's web, it needs to just respond and do what you want it to do. So another example, this is really, really, really common developing web-based apps or PhoneGap apps. In this case, we have a list that's been appended to the body element, and then we have a loop 100 times that our list items are being appended to the list. The problem with this is that the list has already been appended. Then each time we add a list item, it forces a reflow operation in the web view or in the browser. So it's got to calculate the new position, shift everything accordingly, and it's got to do it 100 times. That's going to be slow. However, if you create the list, then you generate all the different list items in a string, and then you create and append the actual list instance one time. It just has to do a reflow operation once. So it creates the elements, does a reflow operation, inserts it. It's much faster on the response rather than the computational overhead that's required to over and over and over and over append a list and then force the browser to redraw each list item and all the surrounding elements based upon the new stuff that you're shoving into the DOM. And then, so in summary, use for PhoneGap application architectures, you want things to be fast. You want to develop for the user experience, not necessarily what's going to be good for you, for the developer. I mean, you want it to be maintainable, but you want to focus on how it's perceived by the user and how they're interacting with it. Strongly recommend a single-page architecture. Use HTML templates to generate your HTML client side. Don't, concatenating strings manually is very cumbersome. It's hard to maintain. Structure your code, MVC patterns where appropriate. If they're not, if you don't need a full-blown MVC, just structure it so that you have modularity as separation concerns. Like you're keeping your code just logically organized, so it's not spaghetti code, it's not a mess. Optimize your data transfer. Abstract components where you need to if you're going back and forth between desktop browser and mobile browser. Optimize for touch. Use hardware acceleration. Optimize for performance. And thank you.